many wonderful hours as a child at night on the beaches of her native Alabama, staring into the stars. Perhaps that's what led her into her lifelong interest and passion for understanding the solar system and what makes things work. It caused her to get very involved in the study of physics, which ultimately led her out to Wyoming, where she studied astrophysics and became one of the experts in land-based observation of solar flares and gamma bursts. Gamma bursts are the biggest explosions in all of the universe. She then became very interested in satellite-based examination and trained and developed and along the way got a PhD and is very involved with the Hinode satellite, which is a Japanese word that means sunrise. She has worked her way back into this part of the country and is employed at NASA in the Marshall Space Flight Center down in Huntsville, Alabama. She's somebody that spends her time looking at our closest star, the sun, understanding it, learning its lessons, and helping to pave a way for a brighter future. We're delighted she's here. Please welcome to the TEDx stage, Dr. Sabrina Savage.
Now, when I was writing up my dissertation work, I encountered some serious writer's block. Now, granted, I had a 12, a 10, a 4, and a 1-year-old at the time, so it's probably not all that surprising that I had trouble focusing, right? But daughter number 2, Elida, who was 10 at the time, wanted to help me out. And so she wrote up a list of things that she knew about the sun, and as you can see, she was a little bit worried about it touching her. Fair enough. But this was a child who had seen lots of pictures of the sun on the computer in different colors and wavelengths, and so she perhaps knew a little bit more than the average 10 or 30-year-old. And she went on to write, "The sun has spots." Excellent. And the sun is a star. And this is the line that triggered me into writing again. If I go into any room and ask, what is the nearest star? About 99% of the time, someone is going to fire back at me with Alpha Centauri. I know some of you were thinking of it. It's like free bird. I know some of you were thinking about that too. But it's not. It's the sun. The sun is a star. Just like any one that you see at night in your favorite constellation, it's no different. And even more than that, it is the closest astronomical object to us. Most of us go through our days not even realizing that we are living with an astronomical object right next to us. And more than that, we're living in it. In its extended atmosphere, its wind, its weather, its tendrils. Sure, most of us are pretty familiar with the first part of her list. It's hot, it's bright, it causes sunburns, and we know that it does good things for us, like grow food with the photons that were created in its core a few million years ago, plus about 8 minutes of flight time. We all know that part, right? It is also the source of nearly every bit of energy in your body, and in the whole solar system even. The sun brought you here today, and you thought it was your Lyft driver. Over 100 Earths would fit across its diameter, and it would take 1 million more to fill it up. And the embarrassing thing is, this star, the anchor of our solar system, which is everything to us, isn't special. It's actually pretty mediocre. If you were at any one of these stars in the Milky Way, looking back with your very own Hubble, you would not be able to distinguish our wee little system from the background noise. Sorry. Our sun will not even have the dignity to explode once it's done burning all of its fuel in its core in about 5 billion years. However, it will go out in a spectacular whimper and take all of the inner planets with it. And yes, you are sitting on an inner planet, such as life. Now, when I first embarked on my career in astrophysics, I wanted to study cosmology, the universe, big things, far away things, Hitchhiker's Guide to the Galaxy things that you needed a TARDIS to go see. I kind of tripped my way down into solar physics, and honestly, I was a little disappointed at first. The sun, after all, is only 93 million miles away. That is peanuts to space, honestly. I thought eclipses were as cool as it got. Now, don't get me wrong, eclipses like this one that went over Nashville just a couple of summers ago are incredible, and I cannot wait until 2024, and you better go ahead and book your hotel for it. But I thought that the sun was boring and flat, and that we knew everything we needed to know about it. It didn't touch me, and it probably didn't touch you before you walked into this room. Let's fix that, shall we? Here is a picture of a planet, Venus, the entire thing. You can even see the atmosphere around its rim. And in the background of this is something straight out of a science fiction movie. That star in the background is so massive that you can't even detect its curvature. And this is your next door neighbor. Now, if we zoom out a little bit and focus on its atmosphere instead of its surface, using more light than what our very limited eyes can detect, you can see this beast in its entirety and admire how gorgeous and complex it really is. And if we sit and stare at it for just a little while, what we find is that it is a superheated ball of plasma that is delicately dancing along writhing magnetic fields. It is constantly changing on all scales. Remember what I said, we're not just living with this beast, we're living in it, in its reach. So anything that happens at the sun can have profound consequences at Earth. And I'll let you in on the secret, stuff happens at the sun. A lot. So remember those spots that were on Elida's list? Those are important. That is where the biggest explosions in the solar system occur. Sunspots are only dark because they're a little bit cooler than their surrounding material, but they would still melt rocks. They look completely static by eye, right? But if you zoom way in on them, they are ridiculously complex and dynamic. In this movie, at its highest resolution, you can pick out features that would fit between Nashville and Huntsville, 93 million miles away. So cool. I love the shot. But what are these, though? Well, to answer that, you have to look outside of the visible spectrum. And what we find is that underneath, they are the locations of the sun's strongest concentration of magnetic fields. And above, they are regions of intensely hot activity, hotter than the surface. These are called active regions, and they are the source of hazardous space weather. And now we have finally arrived at the reason I'm really here, which is to give you nightmares about space weather. So without further ado, let us begin with solar flares. You've probably heard of a solar flare, right? They are the highly energetic burst of light that can occur at these spots when the magnetic field gets so twisted and sheared that it pops, kind of like a rubber band, and then it instantly rearranges itself, kind of like magic, and it releases a ton of energy before settling back down again. Flare temperatures can reach into the tens of millions of degrees, which is hotter than the core of the sun where nuclear fusion is taking place. And yet, flares aren't what should keep you up at night. It is literally the mountain of ionized plasma that can be ejected with these flares. That is the real problem. These coronal mass ejections, or CMEs, can go roaring through interplanetary space at hundreds of miles per second. That is thousands of times faster than an F-18 jet. Now, the sun's activity cycles over about a dozen years. Right now, we are very near solar minimum, very near it. It's kind of boring. And we will ramp back up to solar maximum in about 2025, give or take, which just might coincide with our next trips to the moon. And I want you to remember that in just a second. At the peak of the cycle, CMEs are thrown out at a rate of about several per day. Some are bigger than others, and most of them are not aimed directly at us, because when they are, they can cause a bit of a mess at Earth. Fortunately, Earth has a strong defense